Hello there. So in this video, I want to share with you my current project, and also I want to show you the challenges that I will handle through this project. Okay, so this project actually is just a wireless sensor network. This is one of the node. And as we can see here, this is the main MCU. I will use Atmega 328. Okay, and in the MCU, with the MCU, I will use the NRF for the wireless communication, accelerometer for vibration measurement, and here we have the power supply circuit. And also one of the challenge or the main challenge that I want to handle is the addressing. Since we use a wireless sensor network, so we have more than node, and we have to handle the address to each node. And since we don't have any display, because the main target of this node should be low power, low cost, so I'm not going to use any display. So we don't have display to show the current address, because this address may be in the next videos. I will share with you how I will do, or I'm thinking to do the auto address assignment from the base station to each node. But so far, let's assume the node already got the address. How you going to know this node got which address? So I choose to use a display. I choose to use LEDs, 8 LED, and these LEDs will be display the address in binary. Okay. I use 8 LEDs. So these 8 LEDs is mean maximum 255. Okay, the maximum address will be 255 for each network, and we will use this button here. Okay, this button here to activate the address, or to activate, because this LED will be always off. But once we press this button here, the LED will be shown as the current address. Okay, and the second challenge here is that the LEDs here, from LED 1 to LED 8, they are not in sequence that when they connect to the MCU. I mean, for example, if you see here, this LED 8 here connect to this port, to this pin. LED 7, LED 2, 3, 1, 6, 5, LED 4 here, so there are no sequence. So we have to handle this in the coding also, because there's no sequence here. Okay, why we don't have a sequence here? Because of the routing. So from my routing, I see that this arrangement will give me a better routing without hair wire connection. Okay, this is the best routing I can see so far. Here we can see this is the power supply. Okay, the power supply will be here in the top left corner. This is the input. Okay, these are my 8 LEDs for the addressing. Will be here. Okay, this is a resistor network connected to the ground. Here will be the NRF for the radio communication. Here's the crystal. Here's the main MCU. This is the programming header, and here is the accelerometer, the MPU. Okay, so because of this, so the LED, they are not sequenced, so we have to handle this in the coding. We see how I'm going to handle this challenge also. And again, also because since the address will be in decimal, it will be assigned in decimal from the base station to the node. So we have to convert. We see how to write a function to convert the decimal number into binary, and then we display them, or display the number using these 8 LEDs. Okay, so please stay with me to see how we will go through the software for this for this tutorial or this example. Okay guys, so here I already prepared the code, so no need to start from zero to save some time. So as we can see here, I have declared an array. So because as we talked before that, that the LEDs, the 8 LEDs that I'm going to use for the address, they are not in sequence. Therefore, I will treat them as an array, because the array will allow me to store different numbers, which represents the pin that connected to each LED. So here I have the first LED connected to pin 2, 3, 4, 5, 6, 14, 9, and 10. Yes, here we use pin 14. It's represent actually A0, the analog channel 0, the first analog channel. Okay, and my input, my button, also that we talked about just now, is connect to pin number 15, which is the A1. They are same. You can use either one. Okay, and also I need some variables. The first variable is the address, and the second one is flag. The address is contains 0, and the flag contains number 1. Later we see why we need these two variables. Okay, so in the setup, I make a loop from 0 until 7, okay, to define all the LEDs of I that we already declare here as output. Okay, and for the input, for the tactile button, I declare as input with pull-up resistor. This is the internal pull-up resistor. Okay, now we come to the loop. Okay, first thing in the loop, the first thing I'm going to check is if I press the button. Okay, if I press, because here if I press the button, actually the reading will be in negative, because I already declare as input pull up, so it means already it will be tied to the VCC, so the reading here will be equal to 1. But when the button will be pressed, the reading will be equal to 0. That's why I use negative digital read of input. Okay, so if this one is true, because it's pressed, so it will be negative, and flag equal to 1 also true, we already declare here is 1. Okay, then I will set flag to 0, increase the address by 1, and I will check the limit of the address, because just now we said the limit will be from 0 to 255 according to or due to the 8 LEDs that we have. Okay, this flag, we use this flag here actually to implement this code for once only. If we don't have the flag, if you press and hold the tactile button, this one will be continuously executed. Okay, because whenever you hold the button down, it will be always return back 0. So this one will be always true. So this one will be continuously executed, which means the address increment will be very fast. You cannot control it. So that's why I flag it, so it will be controlled once. So first, when it come here, the flag is 1. So it will go through this condition. Okay, this condition will be true. Then I will break the condition by declaring the flag as 0. When you declare the flag as 0, this condition will not be true anymore. It will be broke, so it will be executed once only. Okay, and the address, we just will use it. We will see later how we will use the address later. Okay, so first function, this is a function actually. I wrote a function to loop the limit of the address. Okay, the address will start from 0 here. Okay, start from 0. Then here, whenever we increase, it will be increased by 1. Then when it reaches 255, it should go back to 0 again. 255 go back to 0 again. So the function actually is here. Okay, this function is to check and update the limit for looping. This one actually is different from the constraint. If you want only to check the constraints, mean if more than 255, it should retain 255, not go back to 0 again. You can use constraint function in the Arduino. No need to use this function. However, I need it to be loop, so I developed this function. Okay, this function, it will take three parameters: value, minimum, and maximum. So if you can see here, it will take the value, which is the address. Minimum should be 0, maximum 255. Okay, so first, if the value or the address is more than the maximum, it will be retain the minimum. This means if it reach more than 255, it will go back again to 0. Else, if we go down, let's say instead of we increase the address, I want to decrease the address. It means address minus minus. So this one will be activated. If value is less than the minimum, is less than 0, so we'll go back to 255 again to the maximum, to return back the maximum. Otherwise, it just return back the same value back to here. Okay, so this one just to increase the address by 1. Okay, so in this condition here, I just redeclare the flag equal to 1 back again. Okay, this one, when it will be executed, only when you release the button. Okay, when you release the button, the reading, as we said, the reading of the in of the button will be equal to high, because we already declare as pull up, and the flag is already 0 because we already set as 0 here, so this one will be true only when you release the button. Then when you release the button, it will reset the flag to 1. So when you press next time, this one will be can be true again. Okay, so next I declare a binary array of 8 elements inside, all with zeros. Okay, the initial state is 0 for all the elements inside. Then I develop another array, another function to convert the address, which is in decimal, into the binary. Okay, this is the function to convert from decimal to binary. Okay, this one takes only 2 parameters, the integer decimal and the Boolean binary array. Okay, that will be stored the binary value of the decimal. So first of all, I will loop from 7 to 0 with minus minus. Okay, it means from 7 to 0. Then I will calculate the power of 2, or 2 to the power of I, which means 2 to the power of 7, 2 to the power of 6, etc. until 2 to the power of 0. I'll calculate the power of these values and check if it's less or equal to the decimal number we already declare here, or we already sent from the main code. If it's less than this, first I will deduct this value, this one, which we already calculate here. I will deduct it from the decimal. Then I will set this pin, what we call this element to 1, which means the element of which one here? This one of 0, because 7 already 7 minus 7, 0. So binary with the element of 0, it will be equal to 1. And then we go back to the next loop or next iteration, where I will be 6, and again we'll calculate 2 to the power of 6. If it's less than the decimal that we already sent from the the second iteration will not be calculated from the one we already sent, actually from the new one, because we already deduct from the previous iteration, and etc. Don't worry if you didn't get the functionality of this one. I will try to explain to you again using the pen and paper at the end of the video. Okay, if this one not true, is mean the power of 2 to the power of I is not less than the decimal number. This one will not be true, so this one will not be executed. So that element will be maintain 0. Okay, that element will be maintained 0. Okay, then after it will be finished, we'll return back the Boolean array back to here. Okay, after we got the Boolean array, then we just loop back again from 0 to 7, and we write the binary array value, we write it to the LED pin. Okay, this one is the LED pin, and this one is the binary value that we calculate using this function. Okay, so let's so that's all for the software. Let's upload and see how it works. Okay, it's computing now. Should be fine. I'm uploading. Okay, done uploading. So let's go to check the board how it works in the real time. Okay guys, so here is a small prototype of what we discussed just now before we finally fabricate the board that we already wrote out and designed in the Eagle. So here's the Arduino, the main MCU. Here are the eight LEDs for the address, and here's the button with the filters to filter out the input. Okay, so this is the first LED, which representing number 1. This is 2, 4, 8, 16, 32, 64, 128. We combine all 255. Okay, so now is 0. We just upload the code. Now when we press this button once, we should see the first LED light up. This means this is 1. Okay, press again. This is 2. Both they are lighting. This means now number 3, 4, 5, 6, 7, 8, and etc. Okay, so here the code, it works, the hardware is okay. Now we already solve the not sequence, or we already succeed to program the 8 LEDs that they are not in sequence with very easy code, very easy way. Okay, plus we convert from decimal to binary to display on the LED. But I want to highlight something, or I want to explain actually the code that relate to the converting from the binary, converting from decimal to the binary. Okay, let's say here we have the number of the decimal. Okay, our decimal is equal to 128. Okay, we want to convert this to binary. So first of all, if you remember from the code, we have loop from 7 until 0 with minus 1. Okay, throughout the loop, first we will calculate the power of 2 with I. With this I actually is this from 7 to 0. So first let's take I as 7. So 2 to the power of 7 equal to this one. When we calculate this is 128. If this value is less or equal from the decimal, this number, 1, which is equal to 128. So 128, is it less or equal? Yes, it's equal. So this if condition, if you remember, there were if condition here. This one is true. So it will go and execute the code. The code is first, it will be deducting the value of this from the current value of the DEC, or the decimal value. Decimal equal to decimal minus power 2 to the I. Okay, so after executing this one, actually the old value is 128 minus this one also is 128, so this one will be 0. Okay, now we will assign 1. Okay, we assign, since this one already declared, so we will assign 1 to the first bit of the binary array. How? By using this code. Binary of 7 minus I equal to 1. I already 7, so 7 minus 7, so this one's mean binary of 0 equal to 1. That means this one will be 1, this one will be 1, and 0, 0, the rest all will be zeros. Yes, 0, 0, 0, 0, 0, 0. Okay, we have 7 zeros and 1, 1. Okay, this is the end of the code. This is the else. Do nothing. Now for the next iteration, the 7 will be 6, the I will be 6. When you calculate the power to the power of the 2 to the power of 6 will be equal to 64. This one will be 64. So 64 for sure is not less or equal, because the new DEC or decimal is equal to 0. This one will be 0 already. Okay, so for sure this one is not less or equal to 0. So this, all the rest of the code will not be executed, will come to here, will be 0. So this one will be maintained. And same to the rest, because this one already 0. So whatever you calculate here, even to 2 to the power of 0 equal to 1, is still not equal or less or equal to the 0. So all the rest will be 0, 0, 0, 0, 0. Okay, so this is our binary array. Okay, so same goes to the any decimal number you can use here, convert from decimal back to binary. So this is the binary array that is going to return back to our code and display here. Okay, this function, since we use 7 to 0, and here also we use only 8 position, 8 element, it can convert the decimal of maximum of 255. This is the maximum. Why? Because we have only 8 elements here, and our loop will be up to 7. If you want more, you can add more here, increase the loop count, and also increase the number of digits here, or number of elements. Okay, so with this we end up our tutorial or sharing tutorial for this video. Thank you very much, and I hope you have learned something from this sharing. Thank you very much, and see you soon with newer tutorials.